Alright, today we're going to talk about adding and subtracting polynomials. So really all we're doing is combining like terms, especially with addition. It makes it a little bit easier. So when we see two groups of parentheses or two polynomials being separated by a plus sign, we're just going to combine any like terms. Now keep in mind standard form, and so standard form says that I want to write it with the highest exponent first all the way in order down to your constant. And so when we combine like terms, they have to have not only the same variable, the same letter, but they also have to have the same exponent. So even though all of these have x's, some have x to the third, some have x to the second, so I can't combine those together. All right, so let's go ahead and take a look. Now this x to the fourth has no other x to the fourth to be combined with. So we're just going to rewrite this. So we're going to write this as 2x to the fourth. Now this x to the third would be next, but again, there's no other x to the third. And so we're going to write it's positive, so plus 3x to the third. Now we would need x squared next. So notice how we have this x squared that again doesn't have any other x squareds between the two parentheses. So we're going to write plus 5x squared. Finally, we have some terms that we can combine. And so we have a negative 3x to the first power and a negative 2x to the first power. So what is a negative 3 plus a negative 2? Right? If I spend $3 and then in addition to that I spend 2 more, it means I spent a total of $5, so negative 5x. Finally, we have this positive 8 being combined with a positive 7, and so 8 plus 7 would be 15. And so this would be our final answer. And notice how it's in standard form, highest exponent all the way down to our constant. Now, number 2, same thing, but there's one difference. When we are subtracting, a lot of times people find it easier to just go ahead and distribute that negative to each term. And when we do that, because we have 4 terms, we have an x to the third, an x squared, and a 1, notice how they're not written in standard form. So when we solve this, we want to write it in standard form. What that does is our first set of parentheses does not change. So I'm just going to rewrite this. Now if you wanted to rewrite that in standard form, you could, but we're going to do that here in a moment. If I distribute or multiply by a negative, all I'm doing is changing the sign. So if my term was already positive, then this becomes a negative. So minus this 2x to the third, minus this 3x, and because this was a negative 4x squared, it becomes a positive 4x squared, and then the negative 1 becomes a positive 1. So distributing a negative or multiplying by a negative 1, it doesn't change the value, it just switches the sign from a positive to a negative. Now, let's try to be in order. So now what we did is we've technically changed this to an addition problem, just like what we had in the first example. So really, let's find our highest exponent. Looks like it's a positive 8x to the third and a negative 2x to the third. When I combine these terms together, I get a 6x to the third. So those are done. Now let's look for x squareds. Well, here is a 3x squared, and here is a 4x squared. So 3 plus 4 is 7, so we get plus 7x squared. Now let's look for x to the first powers. Let's see, I don't have any here. Here is 1, but it's by itself, and it's negative, so I'm going to write minus 3x to the first, technically. Finally, my last thing is this negative 9 and a positive 1 are two constants. And so when I take a negative 9 plus 1, that gives me a negative 8. So this would be my polynomials being subtracted together and written in standard form, starting with the highest exponent first and decreasing by 1 until we get down to our constant.